Why is the sky blue at noon, yet sunsets glow red? Quick answer: tiny molecules scatter short wavelengths much more than long ones, so blue light is thrown around the sky while red travels straighter. In the next few minutes you'll see how path length, our eyes, and even haze shape those colors. No equations, just clear visuals. You've seen it today. Look up and the whole dome seems blue from every direction. Air itself isn't blue, it's nearly clear. The color you see is scattered sunlight arriving from many paths at once, as if the sky were a glowing shell made by countless tiny deflections. Next, why sunlight brings many colors to scatter in the first place. Sunlight is not a single color. It's a blend of wavelengths from violet through red. A prism or raindrop spreads them out because each wavelength bends a little differently. Keep that picture of many wavelengths sharing one beam. The exact wavelength matters because smaller waves interact more strongly with tiny things. When waves meet particles far smaller than the wavelength like nitrogen and oxygen molecules, the light scatters in all directions. That regime is called Rayleigh scattering. Its strength scales roughly as 1 divided by wavelength to the 4th power. Have the wavelength and the scattering jump 16-fold. Blue and violet are tossed around far more than orange and red. You can see a cousin of this at home. Shine a flashlight through a glass of water with a tiny drop of milk. From the side the beam looks bluish because short waves scatter toward you. Look straight through and the transmitted light seems warmer because more blue has been removed. Same idea, just in miniature. At midday, sunlight takes a short, nearly vertical path through air before reaching you. Near the horizon the path is several times longer, so many more short waves are scattered out of the direct beam. What remains pointing at your eyes is biased toward longer wavelengths, yellows, oranges, and reds, so sunsets glow warm. Path length paints the evening sky. If violet scatters the most, why isn't the sky violet? Two reasons work together. There's relatively less violet in the sunlight that reaches the ground, and under bright light our eyes are least sensitive to violet. Blue sits in a sweet spot, strongly scattered yet still detected well by our vision, so the dome appears blue. Long before lasers and satellites, people tried to measure how blue the sky is. In 1789, Horace Benedict de Saussure built a cyanometer, fan of blue swatches to compare against the sky. Explorers like Alexander von Humboldt carried it into the mountains and noted that higher, drier air often deepens the blue. A simple tool, capturing a real change. Later, John Tyndall showed in the lab how tiny particles make shorter wavelengths scatter, more the Tyndall effect. Building on that, Lord Rayleigh worked out the theory for molecules and explained why scattering rises so steeply at short wavelengths. Experiment and math together explain both blue skies and warm sunsets. Scattered skylight has a preferred vibration direction, so the daytime sky is partly polarized, strongest about 90 degrees from the sun. Tilt polarizing sunglasses while facing away from the sun, and you see the blue deepen and lighten as the filter rotates. It's a quick field test that reveals the hidden geometry of scattering. Look straight up and you're looking through less air. There's less added white light, so the blue appears deeper. Toward the horizon you see through more atmosphere, filled with additional scattered light from many directions, which dilutes the color toward pale blue or whitish. Same sky, different path lengths and mixtures. When particles are bigger, smoke, dust, haze, tiny droplets, the scattering becomes less picky about color. That's called scattering. It spreads wavelengths more evenly, washing the sky toward white or gray. After wildfires or pollution spikes, notice how the rich zenith blue fades and shadows feel less crisp. Change the recipe, and the sky changes character. On Mars, a thin, dusty atmosphere scatters sunlight differently, giving a butterscotch daytime sky and occasionally blue-tinged sunsets. Climb high on Earth, and the sky deepens toward navy because there's less air to scatter light. Same physics, different ingredients and amounts. Put it together. Sunlight contains many colors, molecules scatter short waves far more. Long paths remove blue from the direct beam, painting sunsets warm. Our eyes favor blue over violet, haze flattens color. Polarization reveals structure. That's why the sky is blue. Next time, why some planes draw bright white lines while others leave nothing.